Okay. Well, hello, everybody. Chris and I want to welcome everyone, all the NABIT members, as well as the other BSG members in attendance today, to the IUCN Bear Specialist Group North American Bears Expert Team webinar series. This is the first webinar of 2024. Hard to believe, but we've actually been an expert team for about 3 years now. But NABIT webinars have spanned 4 calendar years, so time flies. All the webinars to date are posted on the BSG website, which is now, Dave, I don't know if you've noticed, has exceeded 500,000 visits. So in existence for what, 8 months? So I think it's really gaining momentum and great to see. So nice work on that. As always, we will finish today's webinar within 1 hour to respect everyone's time. And don't forget, you can use the chat function to ask questions at any time or wait until the end. It's up to you, but we will try to ask questions at the end of the presentation. Chris and I will do our best to answer them in order in the order that they're asked. So without further ado, let's get started. Today's presentation is titled Lack of Support for Influence of Bait on American Black Bears Demographics in Maine. It's being presented by Dana Morin. And Dana, I understand you have a couple of co-authors in attendance today, so feel free to introduce them and welcome everyone. Dana, take us to Maine.
All right. So hi, I'm Dana Morin, and I'm presenting some work that we've been working on for a couple of years with my co-authors, Elizabeth Flaherty, who's at Purdue University, and then also Jennifer Vashon, Matt O'Neill, and Craig McLaughlin at Maine Department of Inland Fisheries and Wildlife, and then also Nathan Hostetter, who's at USGS Co-op unit at North Carolina State. So this is a project we've been working on for a while, and the title that I presented in the abstract is the title that will be with the submitted manuscript. But really, when we think about this project, it really becomes central about this one question, which is, could hunting over bait increase black bear population growth, offsetting the intentions of harvest? And I also wanted to, in my, with the points of these webinars, or one of the purposes of these webinars, to be to try to learn from what we're doing in North America, or be able to highlight some of the things we're doing in North America and think about how we can use that more globally for bear conservation. The way I think about this talk for that is thinking about how we try to address management-related questions or conservation-related questions using long-term monitoring data. So data that wasn't designed necessarily to answer these questions, but that we often need to use if we want to be able to make science-based decisions. So for those of you who are not familiar with U.S. geography, Maine is the most northeastern part of the state, up here on the right of the screen. It is heavily forested, very, very, very beautiful, heavily forested, as really low human density, human density. So 17 people per square kilometer. I was reading a paper on a recent population estimate of the bears in the Ouachitas and Ozarks the other day, and their densities are higher. So very low population density in Maine. The black bear population in Maine is actually one of the largest in the East. And this is because there's these really expansive areas of undeveloped habitat that's mostly in the northern part of the state. But bears can be found throughout the state. They can occur throughout the state. These densities are just higher in these primary range in these undeveloped areas. And the Maine State Agency manages the bear population with harvest. They manage population growth with harvest. So between 10 and 12,000 bear hunters during a fall season will harvest between 3,000 and 4,000 bears annually in Maine. And the overwhelming amount of the harvest comes from hunting with bait. And so for those of you who are not familiar with hunting over bait, that's what this picture of the bear down below is showing, is kind of a bait container with the bear. It's a way to attract the bear to an area so that you have a better chance of harvest success. In 2004 and 2014, there were referendums that were put on the ballot in Maine for voters to vote on, attempting to limit or eliminate some types of harvest in Maine, and that included hunting over bait. And one of the reasons that proponents of the referendum gave was they suggested it was ecologically unsound, and their rationale was that that female black bear reproductive recruitment of the population can be really influenced by available food resources, and bait could constitute an additional resource. So if the recruitment was higher, then the population could be growing despite the increased success rate of hunting over bait, and it would offset the intentions of harvest. So there have been some studies related to this recently. So in Wisconsin, there was a study where they showed that some bears could have their diets comprised of a very large proportion of bait. I think it was, some of them got up to like 2/3, close to 2/3 of their diet seeming to come from bait. But they didn't try to link that bait consumption to any demographic consequences. They also in the same study found, or in the same project, found that there might be some negative effects of consuming human food resources or bait, such as reduced hibernation resulting in increased cellular aging. And then in another study in Colorado, they found that female bears that used residential areas more than female bears that did have more cubs per litter. But they also found that the cub survival and the adult survival for those females was lower. And so it actually resulted in lower population growth or reduced population growth. And so one thing to point out about the referendums and the proponents of the referendums in Maine, what they were suggesting is that their claims that they were claiming that reproduction has increased in the state, and that increased frequency of reproduction and increased cubs of litter was contributing to population growth. And so one thing important to note is that wasn't demonstrated with empirical data. A lot of the modeling they suggested was simulation based. And then it's also, they ignored the consequences of consuming bait, that if you're going to be a female bear that spends a lot of time, enough time over bait to actually change your reproduction, that you're also probably more likely to be harvested. So Maine has a really fantastic long-term monitoring program, and we wanted to see if we could link the demographic data from this monitoring program to the diet of black bears, or and primarily to the consumption of bait, to try to answer some of these questions. And so we've got 3 study areas that have been monitored for different periods of time. And I'm not going to go into the details of each of the different study areas, except to say that they vary by the forestry practices in the area, which affect food availability, and especially the amount of human influence in the areas. So in addition to their den check and spring trapping, they also started collecting hair samples from 2005 to 2019. And so this allows us to combine that stable isotope analysis from the hair samples, which should represent the length of time, the diet reflected in a hair sample should reflect the amount of time that since a bear molted, which would be in the spring, until the hair is collected, which would either be in the den. And so that gives a pretty good picture of what they're eating over the summer and into the fall when bait is available. And we had 2 questions looking at, this long-term demographic data, and the hair samples, the type of samples that were collected. We had 2 questions that we thought we could probably answer. And one is, was there greater cubs per litter with greater bait consumption? Is that first suggestion supported? And then also, was there lower female survival with greater bait consumption? So to do that, we first needed to quantify bait consumption in some way. So Liz Flaherty did all the stable isotope work and explained it to me all very slowly using mostly small words so I could understand at the beginning. So this is a very brief description of how the stable isotope analysis works, and Liz will be happy to answer questions afterwards. So isotopes, if we remember back to chemistry, are just elements or atoms that are atoms of the same element, but that have different atomic masses because they have a different number of neutrons in their nucleus. And so it's kind of like these variants of the elements. And so we can decompose food items into their ratio of the heavy to light isotopes in relation to some standard. And that creates a gradient that allows us to be able to visualize these food items in like this kind of isospace and be able to attribute, hopefully, bear diet to the diet items they're eating. So when we look at these charts, when we see on the y-axis, higher values on the y-axis, that's more nitrogen-enriched foods, or bears that are eating more nitrogen-enriched foods. And then along the x-axis, the more you move towards the less negative values, which is actually to the right, that's more carbon-enriched food. So things that we would expect to find in human food, like with human food consumption with corn. So for example, here in this example, it's that they plotted first berries. And so you collect a whole bunch of berries and you get like that centroid in the middle. That's representing the mean value for the carbon and nitrogen signatures for berries. But you also notice there's a lot of variation around that, those error bars around it. And that can be from individual variability in physiology, but also it typically can reflect variation from environmental factors. But what you hope is that when you collect the different food items that a population of animals are consuming, that you've got these distinct different signatures from those food items, so that when you overlay the the isotopic signatures from the animals that you're interested in this case, the example is martins, that you can come up with a relationship. You can see the relationship of individuals that are eating more salmon that are up to the upper right, their signatures are to the upper right corner, and less salmon and more small mammals for the individuals that are more towards the middle of that plot. And so this is what we hope we see when we're doing a stable isotope analysis in this way. So in Maine, we went out and we first collected food items that are in each of that we thought that bears reported to eat in each of the 3 study areas. So we did that in 2020 and 2021. So it's a nice way to spend a lockdown, is walking around the Maine forest and picking berries and flipping rocks to grab ants. So we did it across all 3 study areas because, again, remember, there's that environmental variability that can occur, and we wanted to make sure that we were accounting for that in our samples. And then we also spoke with hunters, and some hunters even provided samples of their bait, but we also analyzed a whole bunch of samples that were representative of different human food items that hunters are using as bait for bear hunting. And so when we plot this out, Liz did all the analysis, and I'll let her answer questions about it. But you look for distinct groups by their signatures. And when we plot this out for the foods that we use, the 483 food samples that we put into the analysis for Maine, we found that 5 primary food groups were identified as being fairly distinct. And so there's fruit and mass down in this lower left corner with lower nitrogen and carbon. And then protein obviously is really high. This is like squirrels and rabbits and things like that are really high up in the along the y-axis. And then what was interesting was the baits, the human foods actually split into 2 very distinct groups. So there were foods that were more low corn enrichment, and foods that had high corn enrichment, like dog food, interestingly, and popcorn, obviously. But foods where corn was really the primary ingredient, or corn syrup was the primary ingredient. And where low bait, the bait that was the low corn enrichment was really things like granola bars, granola, and pastries. So when we look at the bears, so then we analyze the bear hair the same way, and we plot it along the same, we plot it in the same type of space. And so each of these colored symbols is the mean for the bears in a study area in a given year. And you can see there's some really distinct differences in the study areas, right? And that there's definitely some differences in the diets of bears in these different study areas. And you can also see there's quite a bit of annual variation too. So it was significantly different. Their isotopic signatures were significantly different by year and by study area. But when we overlay it with the available food items, we find that they're overwhelmingly eating natural foods, including fruit and hard mast and vegetation. So really tight cluster. And just to give you an idea of like how tight that is, I have a student here who is doing stable isotope analysis in bears in Mississippi in the Delta, where we have a lot of agriculture, and hers are very much more, many of her samples fall much farther towards the less negative corn signatures, or farther along that x-axis on the plot. And so like it really is a very, very heavy reliance on the natural food resources. So, okay, so now we know how we want to quantify, or how we want to look at bait consumption. But and so first we needed to come up with our candidate set and our model. So for the number of cubs per litter, we used den check data from 2005 to 2019. And then we cleaned up the data a little bit in that we didn't want to include females that we wouldn't expect to have cubs of the year that year. So if they had cubs of the year in 2008, they would have yearlings in 2009. So we didn't want to count that as them having 0 cubs of the year. We wanted to only include females that would be expected to have cubs of the year that year in our analysis. And then we came up with our candidate set of hypotheses. So, so we already had information from the den checks on age and study area. We have these carbon and nitrogen signatures and an interaction between them to describe the location in the space. But we really wanted to be able to relate the individual bear's diet to possible bait consumption. And so when we initially wrote the proposal, the idea was to use mixing models, which is a common way of trying to estimate proportion of diet for different food items for individuals. But the problem is that with mixing models, that when you have a lot of overlap, like we have with this bear diet, and probably for a lot of omnivores, when you have a lot of overlap among those food categories, they can become pretty unreliable. It's harder for that model to distinguish consumption of, say, ants from bait from protein. And so we weren't really satisfied with the results we were getting from that. We thought that they looked fairly suspect in some cases. And so we instead reverted to just trying to describe the distance that an individual signature was from the signature of a bait or of the bait. And so this is just pretty simple geometry. So it's just a Pythagorean theorem, right? So the distance of, can you guys see my mouse? The distance of this individual here in red, all the way to the far right, to the mean high corn bait is just the hypotenuse of that right triangle. And so we get that value for distance. And that's obviously different than the distance for this individual here from the blue. And it does have some sort of representation of where these individuals are falling in potential consumption or differences in consumption of bait or human food resources, at least. So, and then remember that we have this significant year-to-year variability even among study areas in the signatures of the bears. So we wanted to account for that in some way. And we didn't have mass surveys for our study areas, but the boreal forests of Maine are contiguous with the boreal forests of the Adirondacks, and there's documented synchrony among many of the plant species and their masting between those areas. And so we contacted SUNY ESF and Stacy McNulty there, and they provided us their mast survey data for the years that we were comparing. And so they have multiple species that they monitor for hard and soft mast, and they rank they have a ranking system for how, whether it's a good year, which is in this middle between the dash lines, whether it's a poor year, below that 1.25 mark, or whether it's a heavy year. And they do it for both hard mast and soft mast. And we were interested in both, but what we saw right away was that there really wasn't any variability. Like if we're using this coarse kind of ranking of scarce, good, or heavy, that there really was no variability in the soft mast. It was good pretty much every year. And so there's nothing to really model there. So we decided instead we were just going to focus on the hard mast in this case, and the variability in there to try to describe the annual differences. And then, oh yeah, and then we had one more issue with our with the data, and that is that we'd wanted to compare the distance of each individual to the high corn bait, the low corn bait, and then the natural food items. But you can see right away when you look at this plot, there's incredibly high correlation between the low bait, the low bait corn signature and the protein, which we would expect to have be a high quality food resource. And we would also expect that the effect might be different. So we decided that because the correlation was 0.98, it really didn't make sense to include both in the model. And so we decided that based on talking with hunters and people in the area, that there wasn't a real distinction between which type of bait, that hunters weren't deciding or choosing baits based on their isotopic signatures. They were choosing baits based on what they thought worked. And so, we decided to make our inference based just on the high corn bait because we were able to get an uncorrelated covariate from that. Okay, so now we have our cleaned up candidate set, and we ran our model to see, we started to run our models. And so first we tried to fit a cumulative link model, which would treat number of cubs as an ordinal integer, right? So that one cub is less than 2 cubs is bigger than 3 cubs, but you can't have 3.5 cubs. So we attempted to use this model because that seemed to be the right one to use. But the problem is that when we ran it, the random effect for individual wasn't identifiable. And so when we did some simulations and played around with it, we found that if we didn't include the random effect for individual, essentially if we kind of pseudo-replicated our data, that it identified some statistical artifacts as being significant effects. And so we didn't want to just ignore the random effect. So instead, we reverted to using a linear mixed model with a Gaussian distribution, just a normal distribution. And we fit that in the LME4 package in R. So. And after all of that, after several weeks of work on getting that all sorted out, we found no support for any of our covariates number of cubs per litter. There was the null model, the intercept only model was the only model that received any support, and all of the other candidate models did not describe the variation in the data. And so when we look at it, at first it was like wah wah, and then you're kind of disappointed. And then when you look at it, it actually kind of starts to make sense when you visualize the data. So the plot you see here is that, the carbon signature on the X and the nitrogen on the Y again. And I'm showing the mean low corn and high corn bait signatures in blue. And then the different number of cubs per reproductive female that would be expected to have cubs of the year are shown in these different gray scales. And then I've just highlighted the 4 cubs in orange to kind of make them stick out, because when you look at the data, there's really no relationship between the signature and the number of cubs. It's really all over the place. So, and when you look at the data, it was, pretty reliably, the number of cubs per litter was about 2.5, pretty consistently from year to year. We know that there's differences in diet reflected in diet from the study areas, but when we look at the number of cubs per litter by study area, there's really no difference, right? When you look at those standard errors. And then if we look at the individuals that had signatures that were falling more along where we would expect to see an effect if there were a greater cubs per litter, we see that that's 1 cub and that's 2 cubs, and that's pretty non-significant. And then finally, we said, well, if annual food availability is going to really affect number of cubs per litter, then we would expect to maybe see a signal between those good hard mast years and those scarce hard mast years. And there's really no difference. If you look at the point values, it's the opposite of what you would expect, right? That it was slightly higher in hard mast years. When you look at those standard errors, they're really identical. So something drives variability in cubs, number of cubs per litter, but it doesn't seem to be related to their diet in this case, or their annual diet in this case. And so we know that female age and body condition absolutely affects number of cubs per litter, but it really seems that when you look at the literature, that it's really more about older females, more mature females that are coming into better body condition as a part of that aging that drives that, or just individuals that happen to be larger or have a propensity to have more cubs. But we're not seeing a difference in these annual fluctuations based on changes in food availability. And when you look at the literature, you see that it's really a lot of the times when we're talking about food availability affecting reproduction or recruitment, it's really more so that a lack of food affects recruitment, in that you're more likely to have reproductive failure in years when there's a lack of food, but not really that you expect to see more, like once they're having cubs, something else, that food may drive whether or not a female has cubs in that year or not, but once they're having cubs, that doesn't seem to be having a strong effect on the difference in the number of cubs per litter. But it did make us think, well, maybe there's some other parts of other things that are affecting recruitment. And so we had this idea. We said, well, if maybe bait is supplementing females in bad years and in years where hard mast is scarce. So if it's affecting females in years that it's scarce, we would expect to see, and that would allow them to reproduce when maybe they would normally. So if we expected that, then we would expect to see a difference in the distance to bait for females in their dens in years that were good versus the years that were scarce. But when we plot that out, again, we see there's really no difference. I didn't put the statistic up here. It's basically, not non-significant, but it's the individual variability in who's eating more or less bait, or whose signature is closer or farther away from bait. It doesn't seem to be driven by that. And so, one of the things that we think about is when we looked at those graphs before, again, of the soft mast, is that there's a ton of buffer species out there, right? There's not the forests in Maine are really ample with food for bears, and so and even when it's a bad year for hard mast, it's still a good year for soft mast, and we know that there can be some buffering from that, and so it just seems that there's not a lot of opportunity in this case for the availability of bait for what's a relatively short period of time in Maine, given their regulations, to really drive anything. So we concluded based on that right now we have no evidence for an effect of bait on reproduction for the study areas in Maine. And then we moved on to, we still wanted to know, the next question is, do we see lower female survival or greater probability of harvest with greater bait consumption? And so for that, we fit a known fate survival model, and Nathan Hostetter gets some credit for helping with this too. His project was a larger integrated population model for the state of Maine, and I basically carved out part of that and then adjusted it to, or rewrote parts of it so we could get questions specifically related to bait. So the model itself, we're using the den check data. So, and as a kind of a capture recapture, a pseudo known fate, but capture recapture model. And each year, a female has a probability of staying alive from that year to the next year, a probability of being harvested in the interim between those den checks, or a probability of succumbing to a non-harvest mortality. And we fit to that model, we fit to the probability of being harvested, the covariates for whether it was a good or a bad mast year, with the idea that bears might be more likely to come into bait in bad mast years or scarce mast years. And then we also fit that distance to the high corn bait as well, to see if we could detect a signal with whether or not they're more likely to be harvested if they're consuming more bait. But the issue with the data, and this is where we work with imperfect data and try to do what we can to get the best answers to make science-based decisions. But the issue with the data is that if it's den check data that we're getting our hair samples from, the female has to survive to the next den check in order for us to have a hair sample from her. And so we know when bears are harvested, and we know when they're succumbing to these natural mortalities, but we didn't have hair samples for them at those times. So we couldn't directly relate whether or not we couldn't directly relate a sample to a female in the year she was harvested. So instead, what we did is we had 1 to 7 hair samples for females across the data set, and we took the mean value of their isotopic signature. And we recognize this isn't a perfect approach, but that it's actually probably overly conservative. If we detected a signal, that the signal would probably actually be stronger. But what we're really looking at is, do you have a propensity, if bait occurs in your home range and you consume it, do you have a higher propensity over time to be harvested? And what we found is that estimated, it fit our expectations, that estimated adult non-harvest survival was really high, 0.98. So if you're a female adult bear in Maine, you're probably not going to die unless you're harvested. And then the probability of harvest was also low, but it was still, I mean, it's still good, 0.15. And we did find that when hard mass was scarce, that there was a greater probability of a reproductive female being harvested. And then we also found that it was slightly higher when individual signatures were closer to bait than farther away. And that signals, that's a smaller effect size. But when you look at the two combined, you see that you have between a bear, like a female bear in a good year that does not consume that much human food resources on average, has a survival probability that's about 0.1 better than a female in a bad massed year that does consume more probability, or more hard mass, or sorry, excuse me, more bait, sorry. So looking at that, we found that individual bait consumption appears to increase the probability of harvest for adults. And so overall, looking at those different analyses, we would conclude that bait should not have a population level effect on recruitment. That the ecological argument is not supported. There are some broader implications. Other states have much more liberal baiting regulations than Maine does. Maine, they're allowed to have bait out for 3 weeks before the hunting season, and then only 1 week or 1 month into the hunting season. And so when you think about the abundant food resources available in Maine, and then the amount of bait that's out there for a short period of time, we might expect to find something different. It's possible you find something different in other states where they have less natural food sources available to them and have much more liberal baiting regulations. But it really does come back down to the fact that bears in Maine are they're really eating a ton of the abundantly available natural foods. And that reproductive success is related to female body condition. We know that, but these arguments that annual variability in food drives cubs per litter were not founded. And when I went back and looked at past studies, the reproductive parameters that are often reported correctly are things like natality or mean litter weight across females, but that's really also including the number of females that just don't reproduce in that year, whether or not they were supposed to or not. So when we look at the proportion on the right, look at the proportion of females with cubs of the litter for the whole population of reproductive females on the bottom compared to the population on the top, we do see some variability in that. And when we use these metrics like natality or mean litter weight across females, that's including that as well as just the number of cubs in each litter. So there might be some misinterpretation of that by the public. Some limitations on this, make sure I'm on time. Yeah, some limitations on this. We didn't have the hair samples from the harvested bears, so we can't directly point at the hair from that season and say that bear was eating more bait that season, and that's why it was harvested, or that's what increases probability of harvest. And it creates a really unique, or a really neat opportunity. So different tissue types like muscle or liver or blood, they all accumulate these isotopic signatures at different rates and retain them for different amounts of time. And it's based on cellular, how it routes to those tissues and then cellular turnover within those tissues. So there's an opportunity where you could collect different tissue types. So it'd be great to collect samples from harvested bears, but if you were also to collect samples from multiple types of tissue that have different rates of accumulation and retention, you could really get a better idea of what's going on. So for example, if we were to collect hair, muscle, and liver from bears that are harvested, the hair would reflect their overall diet for that entire season. And then the muscle and liver, we would expect to start picking up if it was truly that they weren't just eating anthropogenic resources across the season, but they were sitting on bait and consuming more bait, we would expect to see that spike in the muscle and especially in the liver tissue before they were harvested. Just to wrap up some main points. So bears in Maine are not eating a lot of human foods in general. They really just the incredible amount of overlap with those naturally available foods. We didn't find any evidence that that bait consumption would increase recruitment. And this really seems to be a strong public misperception. And when we look at it in the literature, it's articulated correctly, but somewhere between that and where it goes out to being part of the public conversation about conservation, we're losing that that distinction. And so when I think about the IUCN conservation cycle and the 5 elements of it, that really kind of gets at that communication aspect that we need to be thinking about. And then essentially hunting over bait is effective in individuals that generally consume more bait. It seems are more likely to be harvested, which means you would expect them to have fewer total litters total. And then finally, this was during the project, Nathan was doing his project with Sarah and Angela at the same time, and fitting the IPM with all the integrated population model with all the other data. And what they found is a lot of this stuff was going on at a time where they thought the bear population in Maine was increasing. And when they fit the integrated population model, the population in Maine is actually very stable. So there's not actually a population increase to then assume was related to reproduction in the first place. From the bear specialist group standpoint, attempting to address management related questions, I think that a couple points that I was thinking about as I was putting this together is that context is really important. There's going to be ecological differences across species and across regions. And while we often don't have great information about one species or one area, we need to be really thoughtful about what happens in Maine or what happens in Wisconsin may not apply to other areas in the same way. There's also obviously going to be cultural differences and situational differences that we need to consider. But I really think that it's important that we continue to try to make the best use of data to allow managers and people doing conservation to make science-based decision, and recognizing that the best available data may have limitations at times, but we can still, and as long as we're acknowledging those, we can still make good use of that. I'll make a pitch that I really would like to see some of this stuff move into a structured decision-making approach at some point. I think that that's kind of the wave of the future for how we can be making management decisions while considering all of those cultural and situational differences. And then finally, that it'll be really obvious if somebody asks me a stabilized tope question that collaboration is king. Like, it's absolutely necessary. I will not be able to answer it. I will immediately pivot to Liz. And it's been a really fun group to work with. Like, I think that being able to work with people with different specialties allowed us to really exploit the data and the opportunity in its best way, where I could really, Nathan and I could work on population work, and Liz could work on stable isotope analysis, and Jen and Matt and Craig could really contribute on what the situational and ecological differences were. So, and that brings us back to the IUCN cycle as well, thinking about network. So, and with that, I got some acknowledgements for people. Again, just my co-authors have been wonderful on this, and it's been a really great project to get to work on. So I'll open it up for questions, I guess.
Thanks, Dana. You want to just unshare your screen so we can see folks? Thank you. So I did see just one comment in the chat from Joe. He said, "Hi, Dana, great talk. We found differences in body mass, home range size, and reproductive output at Okefenokee that was attributed to bait. So you might check out Dobie et al. 2005.
Yeah.
And of course, that was a different situation, obviously. But the part of the study area in Florida, they didn't even have a bear hunting season, but they had deer baiting.
Yeah.
And they were putting out tons and tons of corn. you know,
Yeah.
for deer. And we felt like it was having an impact on the, and sure enough, we found higher reproductive rates, greater body mass, smaller home range sizes, what you would expect. So, you know, as you know, every situation is a little
Absolutely.
different. And unfortunately, we didn't do stable isotopes. I guess that was before the days where that was very readily available. Wish we had them now.
Yeah. Yeah, no, I agree. It's really going to depend, right? Like it's just the right, and Jen, I think Jen Vashon is on here and she could speak to the regulations better, but like they have pretty conservative baiting regulations. There's Jen, sorry. Yeah. So it's a lot different than like, especially even what we have here in Mississippi with people just putting corn everywhere for deer. Yeah.
Brian, go ahead.
Yeah, I was just gonna jump on after Joe, since I worked on that project and I'm in Florida. The Florida part of that study Joe mentioned, it's not just bait during deer season. They leave bait up all year round. So it's months and months of corn, and it's not necessarily even just at a couple of feeders. They just kind of drive a truck down and leave a line of corn for like a half mile. So it's an unbelievable amount of corn down here. Much longer, could definitely show up in an isotope, I think. Although we've never done isotopes down here for that either.
Yeah, and when you look at like the research from like, you know, the massive garbage dumps and the shutdowns from that and everything, you like, right, it was a huge amount of food availability, right? Like of anthropogenic food availability. So yeah, I definitely can see the differences there.
Thanks, Brian. Go ahead, Dave.
This would be a question, I guess, for Liz, since it's a stable isotope question that I'm sort of confused about. What we see in Minnesota is that we've had some cameras at hunters' bait sites, and we have video cameras on some of the collars of our bears. And they could go to a bait site maybe for 2 days and eat 30 or 40 pounds worth of bait and just scarf it all down, and then that's enough. You know, they don't have to keep coming back. So it's not an extended amount of time, but in a very short amount of time, they eat an enormous amount of food. And if you take a hair sample from the entire year, doesn't that basically disappear, even though it's made a massive impact on the intake of the bear because it was such a short window of time that they consumed it? I think it just becomes negligible and you don't even see it in the hair sample.
I think it was Garth Mowat who said that he has noted, and he hasn't published this, that the diet signature is almost instantaneously assimilated into the hair. But if it's over a very short period of time, it may not be as strong of a signal as if they are going back to that bait pile daily and eating a little bit for a longer period of time. That's where a different tissue might be more useful. So liver would give you the diet over the last week, so you could collect that from harvested bears and have a better idea over a short period of time. But hair is a little bit trickier for sure.
Yeah, and that's the thing that strikes me as different about bait than all of the natural foods, because all natural foods, they're eating them over weeks or months. And a bait literally could just be a few days with a massive amount of food in just a few days. You know, it's like somebody sitting down and eating 20 pizzas.
Mm-hmm.
Yeah, but Dave, if it's like, if their body condition is a reflection of what they're eating over the entire season, then the hair is still going to reflect that, right? Like, even though the bait's a small proportion of that, but it's a large proportion of that day, right? Like, it's not that they eat 40 pounds on one day and that then all of a sudden changes their body condition to an extent that.
I don't know. I think it actually might. I think if you eat 40 pounds in 2 days and then you basically stop eating because that's it. You know, now you eat the 40 pounds and then a week later you go to and hibernate. Like that was the last thing you ate, and it's this massive glut of food. I just don't know. I'm just thinking that it's that the stable isotope signature of a hair sample collected over an entire year, that you just may not even see that.
I would say if that 2 days of food is affecting body condition, then they are probably assimilating a lot of the nutrients from that enormous meal, and it would show up in the hair sample.
Okay. It'd be an interesting test.
Absolutely. That'd be a great captive study.
For captive bears, yeah.
Yeah, especially at least relative to other bears that aren't having that big slug of, right?
Mhm.
Russ, go ahead.
Yeah, I've got a question about kind of along those lines. So the stable isotope ratios you're looking at were from the whole shaft, so they're an aggregation across the year. I'm not an expert in this, but if you did sections of the hair, might that pick up more in Maine where there's a shorter season of baiting versus say Florida where, you know, if there's feeding throughout the year, then you would see it.
So the challenge with doing the sections of the hair is there's so many different things that affect hair growth. So there are people who do sections of the hair and claim it's from a certain period of time, but there's going to be a huge amount of individual variation. And I had a colleague who tried something very similar with coyote whiskers and could never get it to be a reliable growth rate. And I just think with hair samples and so many individuals over so many years, knowing what those segments actually reflected would be really tough. You'd have to make a lot of assumptions.
Thanks, Liz. Go ahead, Joe.
I was just going to mention that we're doing a relocation study where we're taking bears that, you know, are food conditioned or probably food conditioned out of the Smokies and relocating them outside the park and using known fate to see what happens to them. And we're doing stable isotope work on them, and we have found a relationship with their survival rates post translocation and the amount of food conditioning, which is interesting. But what is more interesting is that we have a number of control bears, resident animals, where we're putting these relocated bears in. And we also are doing the stable isotope work on them. And baiting is illegal in North Carolina, and feeding wildlife isn't illegal in Tennessee. But our experiences of working with the landowners and whatnot out there is a lot of bait out in the woods, illegal bait out in the woods, to the point where a lot of these resident bears have higher stable isotope signatures for corn than these so-called nuisance bears that we're moving out there. So that's been a real eye opener. They're consuming a lot of bait, you know, out there illegally. That was kind of an eye opener, as I said.
Thanks, Joe. Dave, go ahead.
This is just a follow-up to Brian's question about sectioning the hair. So we did that. We collected the exact same thing as Dana went through. We collected all these hair samples from Minnesota bears in the dens and tried to relate them to bait use, et cetera. So it's the exact, sort of the exact same study, but we sectioned them into 8 equal sections, which roughly match up to 2-week intervals since they molted. And what we do see is that the only time we see the bait signature is in, like sections number 6. So when you line them up individually, so it actually does show through time that all of a sudden there is a place in the exact same section always where the bait shows up. So even though the hairs sort of grow at different speeds, they grow at different speeds, like not variable within a bear. So like one bear can have a hair twice as long as another bear, but if you section them into equal sections of 8, section number 6 still represents the same time period generally based on what they're eating. I will add also that it is an incredible pain to cut the sections because you lay them down and of course the hair is not straight. And so you have to have a way of laying it down straight. And then when you cut it, there's a lot of static electricity and they tend to move. And so you cut it and all of a sudden you don't realize that section number 3 and section number 7 got switched because they're moving around on the piece of paper that you're sectioning them. And everybody that we've ever hired to section hair samples says they'll never do it again.
Wow.
I would say, Dave, I think it'd be interesting, but like, and I know we've talked about that data before, but it's like one of those things where I'd worry about non-detections, right? Like if you were to compare just section 6, right, to try to get an idea of bait versus non-bait consumption, the ones that didn't have it, like is it that they weren't eating as much bait, or is that the hair got cut differently on that one, or that the hair growth was different? I think you'd want to see it in some sort of model species or like some sort of model system or like a captive study, right, to really confirm that what you're seeing is what you is, like I think it's great you're able to see in section 6 you see a spike in the bears when you expect to, but I'd worry about when you don't, like if that's truly not seeing it or if it's something different, or for feeding it into like these other series of analyses. Yeah.
And we have some captive bears that we actually know, and we fed them specific diets at a specific time of year. And we're doing the same thing to test this to see whether you always see it. So just like you're saying, whether it's detectable or not. And one of the problems that we have with bait in Minnesota is that there's a massive number of hunters that use trail mix. And so that is, primarily nuts and dried fruits, which is very similar to their natural food. And people put out 55-gallon drums of trail mix, and a bear can come over there and eat a 55-gallon drum of trail mix in 2 days.
So Jen wanted me to mention the value of collecting bait rather than using the corn signatures. So we had hunters that donated bait samples and sent those to the isotope lab for analysis, which included donuts and Rice Krispie treats and crackers and gummy bears and all kinds of things that the isotope lab said they had never had to analyze before. But I'm really glad we did that because some of the other studies have relied on a corn signature, and we found that the signature of those other food items was actually very different. So if we'd used just the regular corn signature, it would have given very incorrect results than what we have, which is using the actual food samples that the hunters were using.
And then maybe to follow up on Dave's question too, Liz, trail bait is commonly used here in Maine as well. And so maybe you could address his question or concern about how that might reflect natural foods.
Oh, it would absolutely reflect natural foods as long as they're not using the kind that has a lot of sugar and corn syrup that's added to make it sweeter and more easily consumed. But yeah, the massed samples that we analyzed fell into that natural food signature, and I would assume most of the nuts and the berries within that would all fall into that vegetation signal as well.
Right on. It's 10:02, and I think we'll officially end it there. So if folks need to jump off, but thank you very much, Dana and team, for that presentation. We really appreciate it. It was interesting and thought-provoking, so thanks.
Yeah, very good presentation. Thank you.
Thank you. Thanks for having us.
Bye, everybody.
Bye.